Today, let me go ahead and then start with this Hadoop architecture basically. Okay, so Hadoop architecture. So before we go ahead and then start working on this particular Hadoop architecture, so there are some expectations for this particular Hadoop architecture. Okay, the expectations are going to be like this. The expectations are going to be the point number one. The thing is, there should not be any limit on the storage of data that we need to store. Okay, so that means that either if you have a terabyte storage requirement, or else if you have a petabyte or zettabyte storage requirement, storage requirement. Okay, you should be in a position to store all this particular data. Okay, and there should not be any constraints to this particular storage. So that's why volume of data should not be a constraint basically. You understood? Volume of data should not be a constraint, not a constraint. Okay, and can anybody tell me what is the purpose? What is meant by a distributed system? What do you mean by a distributed system? When can you say a particular system is a distributed system? Okay, we'll be able to say when you're having a cluster of computers, when you're having a cluster of commodity computers, commodity systems, okay, that are linked with the help of a network. Okay, if these things are linked with the help of a network like this, okay, and this particular cluster, what we do is that we call this one as a commodity system basically, or else we call this one as a cluster. So here, assuming that we are having a cluster of systems like this, cluster of computers, and then what happens is that assume that you have a task that has come here. If you are having a particular task that need to be executed, okay, in the case of the distributed computing system, suppose if you are having a program A, okay, I would like to execute this particular program A. So in the case of distributed processing, what happens here? Your program A will be executed in the node 1, okay, as well as it will be executed in node 2, as well as it will be in node 3 also as well. Node 3. It will be executed in node 3 also as well here. Okay, so how they are getting executed, this is something that we need to understand. Program A, node 1, node 2 and node 3. So when program A is being executed by node 1, node 2 and node 3 parallelly, what happens here? If this node 1 fails, you understand what I am saying here? If this node 1 is failing, then will you be able to execute this particular program, Murli? You will not be able to execute that particular program, right? So that's why obviously a Hadoop is a open system distributed framework. Obviously, one of the potential things that can happen is that when you're having a cluster of nodes that are connected together, okay, there will always be 100% chance that some of the nodes will fail. Okay, some of the nodes will fail. Okay, so the primary thing that we need to really look into, the second objective that we need to have here is Hadoop. Hadoop should have a failover capability. Can anybody tell me what exactly is the failover capability? Hadoop need to have the failover capability. Any idea, Kumran? What do you mean by this particular failover capability? Failover capability means
whenever any system is the fail and it transfer to any other node, that is the capability of thing.
Yeah.
That is called the failover capability.
Yeah, exactly. Thank you. Even though if any of these particular nodes are going to fail, what should happen is that Hadoop should have the capability of recovering from those particular failures, okay, and then transfer that particular load, okay, to another system as if nothing has happened. Okay, that is what is called as the failure capability. Okay, and the third objective that you need to really look into is Hadoop whenever you are trying to process the things, okay, what should happen is, let me tell you here. Let me tell you with the help of an example. See here, I have a node 1. I have a node 1, okay, as well as I have something called as node 2, assuming that these are the processors, node 2, as well as I'm having another system called as node 3 is there here, node 3, okay, and here, assuming that you have a combined storage that is existing here, which is nothing but the shared storage, that is what is called as the SAN, right, storage area network. This is nothing but a shared storage. This is nothing but a short storage. Okay, what is happening here is that node 1 is connected here, as well as node 2 is also connected like this, as well as node 3 is also connected like this basically. Node 3 is also connected like this basically. They have been connected here. Now, if node 1 would like to process the data, what has to happen here? And this is the place where your data is existing here. This is the place where your data is existing. Let me tell you here. This is the place where your data is really existing. So what should happen here? Data is existing here. This is the place where your data is really existing. Data is really existing here. Okay, so if node 1 would like to process the data, what should happen? Is it the data should travel to the node, or node 1 should travel to the data? Can anybody tell me? Murli or Kumran? Is it that the data need to travel to the node, or node should travel to this particular data?
Node 1 travel to the particular data.
No. Data has to travel to that node. Why? Because your program, what you are having here, is attached to that particular node, right? Your program is existing here.
Okay.
Your program is existing here. Okay. When your program is existing here and this is attached here basically. Okay. And this is a database here. This is a database. So that means that the data what you are having here should travel to this particular node, as well as the data what you are having here should also travel to this particular node, as well as the data should also travel to this particular node for the purpose of execution. Okay, now how much is your data here? The data is in the form of gigabytes, right? Assuming that the data what you are having here is in the form of gigabytes. When I say that data is in the form of gigabytes, what does it mean? Assume that you have your 500 gigabytes of data that is existing. Okay, and what is your network capacity? The network capacity might be in the form of 100 Mbps at the rate of 200 Mbps. Okay, so do you think that on this particular 100 Mbps network or 200 Mbps network, you will be able to transfer this complete data to node 1, node 2 and node 3 Murli, or this is something that you cannot transfer?
Yeah, it cannot be transferred.
It cannot be transferred. So that's why data is something that should not go through the data is something that should not be transferred through these particular nodes, but instead what should happen is that this should be the programs. Okay, can you tell me whether program occupies much storage or data occupies much storage?
Data.
Data obviously occupies much storage. Okay, when data is expected to occupy much storage, see here, it is the data that should not be transferred. It is only the programs that should be transferred to the data in order to get it processed here. So that's why the third objective what you are having here is that no data transfer should happen. But only the program should transfer. Should transfer to the data. Thereby, it is trying to shave a lot of networking costs for the purpose of doing this particular activities here basically. Okay, so that is what is the thing here. The first thing is that you'll have this terabyte, petabyte and zettabyte volume of data not a constraint. Hadoop should have a failover capability. In case if any node is going to die in between, still you should be able to process that particular node and then get the data. And third thing is that no data transfer should happen because but only program should transfer to the data basically. With this particular objectives, we are going to have this particular HDFS architecture that is coming into the picture. We are going to have this particular Hadoop architecture. Hadoop architecture. Okay, so this particular.
I have a question here.
Sure.
When using the failover thing is happen to everywhere. Like if you have an application server, if you have a database, too many database, red drive, if anything is failover, it automatically transfers it. So
It is
that's
automatically
one transfer to another one. Like that is the failover term, like algorithm. Like if anything is failed, then it automatically transfer to another one. So
see here,
what is the important thing for here is this one.
See here, when I say something called as a failover, the whole node is going to be dumb. The whole node is going to be dumb. That means that the CPU is going to be dumb, the programs are going to be dumb, and the data is also not going to be accessed. So that means that this node to itself is going to be completely taken out. Then what should happen? Obviously, the Hadoop should be constructed in such a way that it should be able to allocate another different node, spin it up, make sure that that node is coming active, and all the data should be transferred to that particular node, and then the processing should start. That is what is called as a failure capability. Okay, and what are the failure capabilities that you have seen in the earlier process of distributed computing system might be happening in small chunks. Either the data might be failed, or else the process might be failed, or else the application server might be failed. But here, what is happening here? The entire node is corrupted, or else the entire node is crashed. In such a case, what will you do, Kumran? You understand what I'm saying?
If, yeah, I understand this.
Yeah,
Ravi,
that's what it is. Yeah, Murli.
go back to that presentation slide, that slide that you. So that program is attached to node 1. Is it like you said, distributed in architecture? That program will run in both node 1, node 2, node 3, right?
In the case of Hadoop, it is supposed to run in node 1, it is supposed to run in node 2, as well as it is supposed to run in node 3 also as well. That means that it is the program that is getting transferred to all these particular places, but not the data.
So the results will also come from node 1, node 2, node 3?
Yeah, the results also will come from node 1, node 2, and node 3. Exactly.
So there should be something like to avoid this like duplication of.
That is the place where MapReduce is going to come into the picture. You remember when I'm talking about Hadoop, Hadoop talks about two things. One is what is that one? One is HDFS, and second thing is the MapReduce. When we talk about MapReduce, that is a place where we are going to do this sort and shuffle process basically, Murli. That is a place where we generally do that. Okay?
Okay.
Yeah, sure. So let us go ahead and start working on this particular Hadoop architecture, and then you'll be able to understand. First thing is that, see here, Hadoop is going to be based on the concept called as the master-slave architecture here. Okay, you have a particular master that exists. Okay, and then you have this particular slaves also that will exist here. Slaves. Master-slave architecture. We have this particular master-slave architecture that exists like this. Okay, now in this particular Hadoop architecture, the first thing what we are trying to talk about is nothing but the storage only we are talking about here. Okay, we are not talking about any terms of processing the data. When we start talking about the processing the data, that is a place where MapReduce comes into the picture. That is the place where MapReduce comes into the picture. So this is the storage what we are talking here. You have the master, along with you have this particular slave here. Okay. Now see what we are going to do here. You have a file. Okay. You have a file which is of something like 600 MB in size. 600 MB in size. Okay. And I would like to store that particular file within this particular Hadoop distributed network. I would like to store that particular file within this Hadoop distributed network. Now, we need to tell how exactly it has to be stored. How exactly it has to be stored. Okay, the master in the case of Hadoop architecture is what is treated as the name node. This is what is treated as the name node here. Okay, and the slaves. Okay, the slaves in the case of Hadoop are treated as the data nodes. They are generally treated as the data nodes like this. This is data node 1, this is data node 2, and then this is the data node 3. We have this data node 1, we have this data node 2, we have this data node 3. These are the 3 data nodes you are having here. Let me tell you, when you have this particular 600 MB of data file, okay, our objective is to make sure that the 600 MB of data file has to be stored in this particular HDFS architecture or Hadoop architecture. Okay, so what we can say here is the name node is treated as the master, and then the data nodes are treated as the slaves. Okay, the data node is the place where your data is expected to reside. The data node is the place where your data is expected to reside basically. Okay, now you have a client. Okay, you know what is a client here. A client is nothing but the machine, is nothing but the application that is trying to store this particular file in that particular network here. So assuming that this is the client that you have here. This is what is the client that you are having here in this particular case. A client is the place. So obviously, what should happen here? Client is something that will approach this particular name node and then saying like, hey name node, I have this particular 600 MB file. Okay, I would like to store this particular 600 MB file in your network. Okay, so that is what we can say here. Then name node, what it will do is that it will never store this particular 600 MB file in a single continuous location. It will never store that 600 MB file in a single continuous location. Instead, what it will do is that it will try to split this particular file into multiple blocks. It will try to split this particular file into multiple blocks. Okay, each block might be either of 64 MB, okay, or else each block might be of your 128 MB size. Each block might be of 64 MB, or else each file will be of this particular 128 MB size here. Okay, suppose if that particular file is going to be of 64 MB, assuming that, okay, how many blocks are required basically? Can anybody tell me how many blocks are required in case if we are going to split that particular file across multiple blocks? How many blocks are required?
Around 5.
7.
We
64 MB.
Yeah, minimum 7 blocks are required, assuming that 7 to 8 blocks are required. Okay. So then what we can do is that we are going to have something like blocks like this. We are going to have something called as the blocks like this. This is nothing but your. It is going to split this particular file. So this is nothing but your file 1. File 1. Okay. As well as this is going to be your file 2. File 2, this is going to be your file 3, like that it is going to split those particular file into something else, assuming that some 8 files it has split it. Okay, and what is the default block size? What I have told you, the default block size is something like 64 MB. The default block size is something like 64 MB basically. Okay, otherwise you can also have the option of configuring that particular default block size into 128 MB also as well. We can also do that one, it should not be a problem. Okay, now using this particular default block size, you want to store this particular data here. Okay, now come here and let me tell you here. This is what is your data node 1. This is what is your data node 2. This is what is your data node 3. Okay, now assuming that I'm having something like block 1. block 1, and then block 2, as well as block 3. 3 blocks, assuming that you're having here. Okay, and here this is DN1 as well as DN2 as well as you're having something as data node 3 that exists. These are the 3 things that you're having here. Guys, is it clear what we are talking here, Murli and Kumran?
Yeah, it's clear. But if you go in your previous slide, you show that the master and slave. The first one, you saying the node name. So what is the benefit for that is in the master part?
I'll tell you. I'll tell you.
Okay.
Let me complete this data node part and then come back and then I'll teach you. Okay?
Okay.
Now, these are 3 blocks you are having here. Okay. What the name node is going to do is that the name node is, who is approaching the name node?
Master.
Client.
Client.
Client is approaching the name node. This is the client that is approaching the name node, and then saying that I'm having a file which is of 600 MB size, okay, and then I want to store that particular file in your Hadoop architecture, okay. So he will be approaching the name node, okay. Name node being a master will be able to know what are all the data nodes that are available. And within each and every data node, how much is the memory space that is free for the purpose of storing these things. So that means that all the information with respect to this particular name nodes data nodes, in terms of the size, the available free space, the occupied free space, it should be available within this particular name node. Okay. For that particular purpose, name node is expected to maintain one type of information, okay, that is what is called as the file system metadata. Salim, is it clear now what we are doing here? Murli?
Yeah, clear.
It is treated as the file system metadata here. It is treated as the file system metadata in this particular case here. File system metadata here. This is data node 1, data node 2 along with this particular data node 3 that exists in this particular case. Okay. So now it will take this particular block 1. Okay. And then what it will do is that assuming that the name node identifies that there is some available space within this particular block 1. So what it will do is that it will take this particular block 1 information and then start storing that particular block 1 here in this particular data node name 1. It is stored here. Okay. And tomorrow, if this particular data node 1 is going to crash, then what should happen?
Available in block 1 or available in DN1, you mean?
This data node 1 is stored in, block 1 is stored in DN1, data node 1, that's what I'm saying. Okay. Block 1 is being stored in data node 1 here.
So name node master knows that there is some space available in DN1.
Yeah,
so
yeah.
There's block 1 in DN1, right?
Yeah, it shows the block 1 in DN1. Okay. Not only that it is going to store the block in DN1, what it will do is that for every block that you are going to have, okay, it is going to maintain 3 copies within the entire networking system. 3 copies. Okay. So it will store this block 1 here as well as it will go ahead and then store this particular block 1 here also as well. As well as it will also store this particular block 1 here. And assume that there are not only 3 data nodes, but there are multiple data nodes here. So that's why block 1 is associated here also as well as block 1 is associated here also as well. So Murli or Kumran, can you please tell me what is the advantage of this particular process? Kumran, what is the advantage of having this particular replication that is being done here?
If anything is failover, you can be recovered. It's simple.
Yeah. Tomorrow, if any node is going to fail, going to fail, what we need to do is that we should be in a position to divert that particular process to that particular the remaining nodes, in order to access that particular data. That is what is treated as the failover capability. Okay, that's why in order to support that particular failover capability, what this Hadoop will do is that for every block that you are going to have, okay, it is going to maintain 3 copies. So that's why, coming back to the previous slide, assuming that if you are having 600 MB of data that need to be stored, how much is the total storage that is required in order to store that particular 600 MB of data? How much should be the total storage that should be required? (1800 MB of data is 18 MB of free space should be required in order to store that particular 600 MB of data. You got this point?
If there is no space in one particular, let's say, data node 2, is it needed to store in all the data nodes, like, or only like whichever is available?
Yeah, can you please repeat the question, if you don't mind?
Let's say block one master knows that there is a space only in DN1 and DN3, but not in DN2.
Okay.
So, my question is it mandatory to, or is it a requirement to store in all the data nodes?
See, let me tell you. Whenever we talk about the big data, okay, in any of the implementations, the big data is expected to have minimum 15 to 20 nodes within a cluster. That is the minimum acceptable criteria. Okay. Now, one more thing. If you are not really interested, okay, to replicate this particular data across all the data nodes, then what you can do is that you can try to limit yourself your replication factor. You can keep your replication factor as 2. Should not be a problem. Even if you don't want to replicate the data, you can always keep the data as replication factor as only 1. Then it will not be a problem. But the best practices for which this particular HDFS has been created is it normally suggests you need to have. It normally suggests you need to have this particular. You need to have this particular HDFS. You need to have this particular HDFS with a minimum replication factor of 3. That is the reason we are trying to store it in 3 blocks basically, Kamran. Does it clear your question?
Yeah, it is clear. So that the replication factor is configurable somewhere, right?
Yeah, replication factor can be configurable. And another thing, whenever you are working on your practical demonstrations, okay, you will be working only on a single node, right? Single node Hadoop cluster you will be working on. When you are working on a single node Hadoop cluster, you are going to have only one name node as well as you are having the data node installed on the same machine itself. Okay, in such a case, what can happen? I cannot put multiple replications on the same node, right? I cannot put multiple replications on the same node. When I start putting multiple replications on the same node, what happens? If that node crashes, then obviously there will be no source through which I will be able to retrieve that particular data. So that's why, if at all, if you are trying to maintain the replication of these particular blocks, okay, it should always be on the different nodes, but not on the same data node. Okay. Murli, is it clear to you?
Yeah, clear. Yeah.
So right now, if you are having this 600 MB of data, how much amount of free space should be available? You should have something like with the default replication of 3, you need to have this particular 1800 MB of free space that should be available. Okay. Now the next point, let me talk here. See, this is all happening internally only. This is all happening internally only. Okay. But from the client perspective, what happens is it appears as if it is only a single logical file. It appears as if it is only a single logical file. That means that I hope you are aware of this particular Unix commands or Linux commands. Okay, when you go ahead and then start issuing the command like ls, okay, at that particular root prompt, what happens is that it gives you the file as only as a single file, but it will not say you that this many number of data blocks it has been divided, or else that information will not be given to you basically. That information will not be given to you basically. So at an outset, this is what is this master-slave architecture here. We have multiple data nodes. You have this particular name node, and the name node is going to maintain this particular file system metadata. So can anybody tell me what should be the components or the contents of this particular file system metadata, and what is for used here? So this is your name node. This is your name node, and for this particular name node, what you're having here is that you're having something called as file system metadata. Okay, and this is the client. This is the client that is approaching this particular name node like this. That is approaching this particular name node like this, and this is what is your name node metadata. And obviously, what you're having here is that you have this particular data nodes that are existing like this. These are your data nodes. This is one data node. This is what is your second data node. 1 minute. Second data node, and this is what is your third data node. These are your 3 data nodes. Okay. Accordingly, what you're having here is they are connected basically. They are connected. Okay. So if we have a file, let me tell you here. If you have a file, okay, that file is divided into 3 splits. What is the 3 splits here? This is file A. This is file A, and you have this particular thing as file B, and you also have something called as file C. So assume that the file is divided into 3 splits like this. Okay, or else it is divided into 2 splits only. Assuming that to be on the safe side. 2 splits it has been divided. Then what happens here? You have your file A. You are having your file A that is existing like this. You assume that you have your file B that is existing on the data node 2. Okay, and you have your file A and B existing on file A and B existing as replication copies in data node 3. Okay, this is node 1. This is node 2 as well as this is node 3. Okay. What does your file contains here? It stores like this. We have this particular file, okay, which is split into 2 things. One is nothing but your file A, into 2 things which is nothing but your file A, and which is split into your file B like this. Which is split into your file B like this. Okay, file A. Whenever you start taking something else file A, you need to understand 2 things here. File A is existing in 2 nodes. What are the 2 nodes here? Assuming that it is existing in 1,3, as well as file B. What you are having here is also existing in what we can say here. It is existing in 2,3.
2,3.
Yeah, that is how this particular information is being maintained in this particular name node. You understood now what is the purpose of this name node, Murli and Kamran?
Yeah. Basically, it's just maintaining the content of the file, and whenever you want to point it, it can point to the right node.
So it is not maintaining the content of the file; it is maintaining the metadata content.
Metadata of the content. Just for the.
Yeah, it is trying to maintain the metadata content of the file. Okay. Now let me tell you how this replication is expected to happen. How this replication is expected to happen here. See here, the client approaches the name node. Okay, the name node says that I have this particular file. Okay, where I have split it into file A as well as file B. And what it will do is that the name node will go ahead and then start. Writing this particular file A into this particular first node. File A into this particular first node. It writes that one. Okay. Then what it will do is that as soon as this is written, then what it will do is it will get the information from the name node saying that as soon as you write your copy, you please go ahead and then start writing the second copy within this third name node. within this particular third name node. So that's why name node is only responsible for the purpose of writing the first copy of that particular file in a particular local data node. Okay, but the subsequent things what you're having here will be written by the corresponding data nodes. So that means that the data node will write the second replication copy into data node 3, and the data node 3 again will start writing the replication block into this particular data node 5, whatever it is. So that's why this is going to be a sequence that is going to happen here. Okay, so what we can say is that the first file split is going to be written in parallel, okay, whereas the replication things what you are having here are written in sequential in this particular case. Is it clear to you, Salim, sorry, Murli and Kamrun?
Yes, it's clear.
Okay.
Yes, it's clear.
Now the question is that I was telling you something like there are some nodes that will die in between, right? That will
Ravi,
get down in between.
Ravi, so in this particular thing, like file A is written into, let's say, node A.
Mm-hmm.
So node A should know the file B has to be written into node B, right?
Mm-hmm.
That information is like, how does it know about that information?
That's what I'm going to ask you. That's what I'm going to ask you. How it is going to happen is
master is going to send that info, like.
Actually, what happens is, let me tell you. Whenever this network starts, whenever this particular cluster starts, okay, for every 3 seconds, every data node is supposed to send an heartbeat to this particular name node, saying that, hey name node, I'm alive, and there is data in my name node, and there is data in my name node, as well as there are some processes that are running in my name node. So that means that this name node 1, sorry, data node 1, data node 2, as well as data node 3 are expected to pass heartbeat intervals to this particular name node 1, heartbeat intervals to this particular name node 2, as well as heartbeat interval to this particular name node 3 every 3 seconds. Okay, so that's why it will be able to know that the name node will be able to know that data node 1 is working, data node 2 is working, or data node 3 is working. Okay, by somehow, if it's not able to receive any heartbeat from this particular data node 3 to this particular newly instantiated node, basically. So that's why at every point of time, then it is the responsibility of the name node to ensure that okay, the process is going uninterrupted. At the same time, you should see that the replication factor is being maintained as by the decided criteria, basically. So that's why, to answer your question, every name node, every data node, for every 3 seconds, it is going to give a heartbeat interval, saying that it's going to give an heartbeat interval to these things, saying that, see here, saying that I'm alive. But for every 30 seconds, what it is going to do is that it is also going to send the block report also as well. Block report. Okay. So if you want to really understand what is this particular block report, let me tell you here. Block report. What is the purpose of this block report? The purpose of this particular block report is it says that the number of the files that are existing here, the blocks that are existing here, along with the number of amount of free space that is available, that information also will be given here. Okay. Based on the information that is being separated from the data nodes to that particular name node will be in a position to decide. How much amount of free space will on each and every data node, and what should be the case. This is how they are going to have a continuous interaction between these particular name nodes and data nodes in order to take up this particular process. Is it clear, Murli and Kundan?
Yes, clear. But I am thinking about that. There is it's too many times. Like his heartbeat is going and sending a message to name node. Is the processing wise fast? Is it slow?
Heartbeat is only trying to ping the server. Heartbeat is trying to ping the server, saying that I'm alive. Okay. Block report is saying something like not only that I'm alive, this is what is the complete metadata information that I'm having, and based on the information that is being supplied in the block report to that name node is going to update its metadata based on the block information that it gets from this particular data nodes. Okay.
Okay.
So that's why there should not be any question of how many maximum number of times this heartbeat is going on. It has to go as long as this particular networking is running on. Because whenever you try to see this particular big data Hadoop cluster, it is not a cluster of machines having 10 or 20. It is nothing but the cluster of machines having 50 to 100 or 30 to 40 machines within the cluster. So that's why this is a common phenomenon that should happen in order to do this particular process case. Okay.
So in this example, Ravi, like file is split into file A and file B, right?
Yeah.
So master name node writes file A, the part of the file A, into data node 1, right? So the file B part, you said data node A, data node 1 will write into data node 3.
Yeah.
File B part. So my question is how does the data node 1 knows about the data node 3?
See, that information is also being supplied by the name node only.
So the remaining file you write in data node 3, it will send like that?
Yeah. See, what it says is that when the name node is passing the information to the data node 1 for writing this particular A block, okay, what it says is that as soon as you complete this one, okay, please take the task of writing the replication onto this particular name node 3. That information is also being supplied by the name node only.
Replication only, okay.
Replication only.
The same file A will be written into data node 3. That information
exactly.
is massive.
Yeah,
okay.
Exactly. Yeah. Got you?
Yeah, I got it.